So we've seen this different syntax, but we haven't really seen like what the benefit is. So far we've seen some of the costs of Elm. You have to learn a new syntax, but we haven't really seen any of the benefits yet. So let's talk about those briefly. So in JavaScript, let's say we write our pluralize function. We say pluralize leaf leaves in 1, and it works out. If we say pluralize leaf leaves in 3, it again gives us the correct answer. But now let's say we make a mistake. So instead of returning singular, we return singula. That's a mistake. That singula is not a thing. That doesn't exist. So what's going to happen if we do this? Well, if we say pluralize leaf leaves in 3, nothing's going to happen. It's still going to work because by coincidence we didn't happen to traverse the path that led to the bug. If, on the other hand, we say pluralize leaf leaves in 1, it's not going to work. What's going to happen is we're going to get a runtime exception. Uncaught reference error, singula is not defined. Which, yeah, okay, fair enough. Indeed, it is not defined. So this would be an example of a crash. Not really what we want to give our users in terms of user experience. Now TypeScript will do a little bit better than that. In TypeScript, if we write this same code, we'll get an error. It's like error TS2552 cannot find name singula. Did you mean singular? So it identifies at compile time, this is a mistake that you made. I know that there's nothing named singula in scope here, so you need to fix that before we will compile the program and actually run it. How about Elm? If we make the same mistake in Elm, we say singula instead of singular in the first branch of our if. Similar kind of thing. Cannot find variable singula. Maybe you want one of the following, singular. So again, this is much like TypeScript, Elm is able to catch this at compile time and prevent that runtime exception. Okay, let's look at a different error. Let's say in JavaScript we say if quantity triple equals the string 1. Now when we say pluralize leaf leaves in 3, it still works. Pluralize leaf leaves in 1, now it's back to the original broken case where things are not working properly anymore. So this is also not what we want. The whole reason we wrote this function was to avoid this edge case bug from happening, and here we've made a mistake that is still going to result in that bug being present. Okay. So the root of that problem, by the way, is that the string 1, when compared with triple equals to the number 1, returns false. Those are not considered to be the same thing in JavaScript. And in TypeScript, same thing. This will compile, this will run, it just won't work properly. We will still have this bug materialize at runtime. What about an Elm? Well, in Elm, this actually won't compile. It'll say the third argument to function pluralize is causing a mismatch. That is to say, when we're calling pluralize up here, the third argument is causing a mismatch. Function pluralize is expecting the third argument to be a string, but it is a number. So essentially, Elm was able to figure out, you know what, this is going to be a bug. If we write this expression, this is always going to fail. Something is off there. I'm going to tell you about it at compile time and ask that you fix it before you actually run this application. The way that Elm's able to do this is using what's called type inference. So it essentially knows about all the types that are in your program by sort of doing a process of starting off with some facts that it knows, like 1 is a number, leaves is a string, and then going through and figuring out implications of those facts. So it says, okay, well I see that here you're comparing quantity to a string, which means quantity must be a string, but here I see that you're calling it passing 1 for quantity, which is a number. So how can it be both a string and a number? Something is off. I'm going to tell you about that. That's an error at compile time. Elm does type inference across everything, and I do mean everything. So there's no any type like there is in TypeScript. There's no escape hatch where you can say, trust me, I know what I'm doing. Elm's compiler really does do type inference across 100% of every single value in your entire Elm program and all the packages in the entire ecosystem. This is how we're able to avoid runtime exceptions. Fundamentally, it's the combination of Elm's insistence on doing type inference across absolutely everything and the way that the libraries are designed, which we'll learn about through the course of the workshop, that sort of prevents this from happening. So yes, there is some new syntax to learn. There is some different concepts to master. But ultimately, the guarantees that this provides and the reliability that results from that is a pretty serious benefit.